So we're going to look at a couple of example problems here where we're using the definition of limit to answer some problems about functions. These are similar to some homework problems that you're going to be asked to do. We will have a second video where we look at some other kinds of problems using the definition of limit. Those ones will be proofs, but these are more numerical problems with specific functions and numbers. So whenever we use that definition of limit, we need to show that for each positive value of epsilon, so sometimes we write that epsilon greater than 0, we can find a positive value of delta, so there is a delta greater than 0, so that whenever x is in the domain of the function and 0 is less than the absolute value of x minus a is less than delta, we're guaranteed this last inequality that the absolute value of f of x minus L is less than epsilon. So when you think about that, you should be able to think about what you would use to fill in these blanks that tells us what x has to be between and what x should not equal, and that will ensure that f of x is between some things that we can put in the blanks. So you might try thinking about what goes in those blanks, pause this video, and see if you can write down what would go in those blanks, and then you can restart the video and see if you were right. Okay, so hopefully you tried to figure out what goes in those blanks. So we know that this part of the inequality about the x's and the deltas tells us that x is going to have to be between a minus delta and a plus delta. And we know that x should not actually equal a. We want to be close to a, but not at x equals a. And then that will ensure that the f of x's will be between L minus epsilon and L plus epsilon. We drew some pictures on a previous video where we looked at that on the graph. Okay, so I'm going to scroll up and let's do a couple of problems using that definition. Okay, so this is similar to some of the homework problems that you have. Many of the homework problems that you'll look at actually only ask part C and may not ask the information in parts A and B, but you really have to be able to do those parts in order to answer C. So even if they don't explicitly ask you for these things, you might want to write these things down to organize your work before you jump into the problem. Okay, so the function we're working with here is a really easy function that we can probably figure out what that limit is without having to think too hard. This is a polynomial function, so we can use a substitution shortcut theorem. I'm just going to abbreviate that. It'll be the one for polynomials that tells us that we can use substitution to figure out that the limit is 2 times 3 minus 1, or 5 is the limit that we're after here. Okay, so for this specific limit, we want to think about what are the values of a and L, and what is the function f of x that they're talking about, so that when we work on our inequalities we can put those values in the right places. Okay, so x is approaching 3, so that's our a. F of x, that's our function. We have f of x equals 2x minus 1, and L, or the value of the limit, is 5. Okay, so we now are going to use that information to figure out a delta, so that when x is in the domain of the function and the first inequality is true, we get the second inequality. Alright, so I'm going to just write down those inequalities with our values plugged in that we have for this problem. So I have 0 is less than the absolute value of x minus, and our a is 3. And that's going to be less than delta. Delta is what I'm trying to figure out here. And I want that to imply that the absolute value of our function, 2x minus 1, minus the limit L, that's 5, is less than, and then this part of the problem they told us to use an epsilon value of 0.1. So I'll put that. Alright, so I really have two parts of the problem to work on here. The definition has an implication that goes one way. For each epsilon there is a delta, so that the statement about delta will imply the statement about epsilon. So we're given an epsilon and we're going to kind of work backwards to figure out what is the proper delta that would make that implication true. So we're basically just going to do some algebra here and try to match things up and make things work. So as long as you're doing correct algebra, there's several ways to do this problem, but I'm going to show you what I would do. Alright, so one thing that I would do here is start with the inequality that involves the delta, and I'm going to rewrite that as negative delta is less than x minus 3 is less than delta. That's a good first step in a lot of these problems, is to open up that inequality and get rid of the absolute values. It can just be a little bit easier to work with. All right, for the other inequality, I'm going to do the same thing, but I think first maybe I'll go ahead and combine the minus 1 and the minus 5. So I have absolute value of 2x minus 6 is less than 0.1. Okay, so then I'm going to go ahead and open this up, and I have 0.1 is less than 2x minus 6 is less than 0.1. Okay, so something that jumps out at me in this problem is noticing that if I look at the last inequality I just wrote down, and notice that if I divide through by 2, as long as I'm dividing by a positive number, I don't run the risk of messing up any of the inequalities, then I will have negative 0.05 is less than x minus 3 is less than 0.05. And what's helpful about that is that I now have x minus 3 in the middle of that inequality, just like I had on the other side. And then maybe you can match up the rest and figure out that the delta value that you're going to need to use for this problem is 0.05. So we're just kind of matching up those inequalities. Remember that you can always use a smaller value of delta, because a smaller value of delta would certainly trap those y coordinates in that same region as well. So this would be one value of delta, probably an answer given in your textbook or in your homework, but you could also use anything smaller as long as it's a positive number. Remember, your delta has to be greater than 0 though, so you wouldn't want to use 0 or a negative number. Okay, so let's scroll up and look at another problem here. This one is a different function here, and it's given to us kind of in the form of a graph instead of in mathematical symbols necessarily. So we kind of have to look at the graph and interpret that a little bit. I have the function y equals 3 times the square root of x plus 1. I see all these dashed lines. On the y-axis, I notice I have some dashed lines centered at 6, and then up to 6.3 and down to 5.7. On the x-axis, I have this region around 3. So this looks like some of the pictures we looked at before, and would be indicating a limit as x approaches 3 of the function, 3 times the square root of x plus 1, and that limit looks like 6 on the graph. And you can verify by substitution shortcut theorem that yes, 6 is the limit of that function as x approaches 3. Okay, so now we want to identify these pieces so we can use them in our work to figure out what they're asking us to find. Again, on these problems, the textbook homework and the online homework usually just ask for this last part, but you need all these pieces to do the last part. Okay, so our function is 3 times square root of x plus 1. The a is 3, that's what the x is approaching. L is 6, that's what the y values are approaching. And then epsilon, on this one, we're going to have to look on the picture and think a little bit about epsilon. So remember, epsilon is a distance in the y direction above and below what we claim the limit is. So if you look at that picture, you can see that those two values at the top and bottom dashed lines are 0.3 units away from 6. So that's our epsilon. Okay, so now we need to find the delta that makes this implication true. So we're going to scroll up and do a bunch of algebra. Okay, so I'm going to go ahead and write the problem out here, just kind of like we did with the last one. Really have two inequalities to work with. So the first one, 0 is less than the absolute value of x minus 3. 3 was our a, is less than delta. Delta is what we're supposed to find. And we want that to imply that the absolute value of our function, which was 3 times the square root of x plus 1 minus L, our L was 6, is less than epsilon. And our epsilon was 0.3. Okay, so again, we're going to essentially work on one piece of this and try to match it up with the other piece so we can figure out what our delta is going to be. So I'm going to rewrite both of these inequalities without the absolute value bars. For the one with delta, I'll have negative delta is less than x minus 3 is less than delta. For the other one, I'll have negative 0.3 is less than 3 times the square root of x plus 1 minus 6, and that's going to be less than 0.3. Okay, so for the last problem, we basically did 1 or 2 steps of algebra, and then the two sides, the two inequalities we were working with, matched up, and it was easy to figure out the delta. This one's a little bit harder, so just kind of think through some algebra. As long as you're doing algebra that doesn't violate the inequalities, or making sure that you're doing the same thing to all the different parts of the inequality, there's a lot of ways to do this problem, but I'm going to talk through what I would do. Okay, so I'm essentially going to try to force the middle of this inequality to be x minus 3, because that's what I have in the other inequality. So the first thing I would do is probably add 6 to the middle, and then therefore you have to add it to each end. So I would have 5.7 is less than 3 times the square root of x plus 1, and then that's going to be less than 6.3. Okay, I would probably next divide through by 3. All right, so 5.7 divided by 3 is 1.9 exactly. And then in the middle we'll have square root of x plus 1, and then 6.3 divided by 3 is 2.1 exactly. You want to be careful about rounding in these because we're dealing with very tiny numbers and trying to make sure everything comes out perfect. If your numbers don't divide in exactly, just leave them in the form they were in before, and worry about rounding at the very end. Okay, so the next thing I might do is square to remove the radical. You do have to be a little bit careful about squaring with inequalities and making sure it doesn't violate the inequalities. But because all of the values we have here are positive, a positive 1.9 and a positive 2.1, and then the expression in the middle has to be between those, when we square positive numbers, the inequalities are preserved. But if I had some negatives, I would have to be careful about that. Okay, so on the left end, 1.9 squared, we get 3.61. I'm not rounding again, I'm just keeping all the digits here. In the middle, the square will undo the square root, and I have x plus 1. And on the right end, I will have 4.41. Okay, I'm going to do a couple more steps here. I think I'll subtract 1 from everywhere. Again, there's more than one way to do this algebra, but you should end up at the same place at the end. Alright, and remembering that I want an x minus 3 in the middle of my inequality, I'm going to go ahead and subtract 3 from everywhere. Okay, so on the left end, 2.61 minus 3 is negative 0.39, and that's going to be less than x minus 3, which will be less than 0.41. So I have the x minus 3 in the middle as I wanted. Okay, so one way that this problem is a little different than the other problem, though, that we looked at, is that these two expressions on the end are not just the positive and negative of the same value, like in the last problem we looked at. So delta can't be both of those values. It has to be one or the other of those values. So I need to think a little bit harder on this one about what my delta is going to be. So I basically have two candidates for delta. Delta could be either positive 0.39 or it could be positive 0.41. Remember that delta is never negative, it's positive, and this inequality would represent a plus and minus perhaps. So I have to think about which of those is the correct answer for delta. And remember that we can always go smaller, but you can't go bigger or the function is maybe not going to fit in the correct interval. If I scroll up and look at the picture, you might notice that one side of this function is slightly steeper than the other, and this interval looks slightly bigger on one side than the other. So I always want to go with the smaller side. The smaller side in this one corresponds to that 0.39. That would be the value of delta for this problem. Delta equals 0.39 or anything smaller. All right, you might try some of the homework that involves the numerical calculations, And then after you try that homework, then maybe watch the next video and try some of the homework that involves proofs.